Hi there, so do now number one. Right, we're going to have 5 minutes to do this. I'll start the clock in a second and I'll turn my mic off. You must have a go at every question. It's so important that you just have a go. Put some working out down. Don't just write a number, put the actual working out down and just have a go. And if you get it wrong, you get it wrong. Just make sure you listen to my explanation afterwards. You've got 5 minutes and that time starts now. 3, 2, 1, and time's up. Okay, right, let's get marking. Let's get rid of that clock. Right, the next two terms in each sequence. When you've got a sequence, each one of these numbers, or if it's a sequence of patterns, each pattern is a term. And so if we want the next two terms, we want the next two numbers in the sequence. Let's have a look at the sequence and see what's going on here. Now, we are adding 3 every time. It's going up in threes, which means if I add 3 to the last one, I get the next term. And if I add 3 again, I get the term after that. Okay, so 20 and 23 being the next two terms. Now this one can't be quite the same because if I added on here, I'd only add 4, but then suddenly I'd have to add on 12 to get to the next one. Now what's actually happening here is we're multiplying to go from one term to another. This time we're multiplying by 3. So 2 times by 3 is 6. 6 times by 3 is 18, and if I want the term after that, I will have to times 18 by 3, which is 54. And if I want the term after that, I'll have to times that by 3, which is 162. Okay, sequences like this that are multiplying, geometric sequences we call them, they get big very, very quickly. Right, the next one, write down the nth term of each sequence. Okay, so here's the sequence. Now it's actually the same as my first sequence up there. So I know what's happening from term to term. We are adding 3. So add 3, add 3, add 3, and so on. So I need to add, well, I'm not adding 3, I'm sorry, distracted by someone doing a delivery. Right, back onto this. It's the nth term. If it's going up in threes, then that means it's a bit like the 3 times table. Now we write this as 3n. Now it's the nth term, so n obviously needs to appear. Every term is changing by 3, so the 3 goes with the n, right? Now this makes the 3 times table by changing n as, first of all, 1, so 3 times 1. And then n is 2, so 3 times 2, which is 6. And then 3 times 3, which is 9, and then 3 times 4, and so on. That makes the 3 times table. That's what 3n is. Okay. Now, my sequence, though, isn't the 3 times table. If I look at this, if I actually write the 3 times table above it, you'll see that clearly it isn't. But it is kind of close. It's going up in threes, and actually each one of these is only 2 more. My sequence is actually only 2 more each time, which is why it's 3n plus 2. Now this plus 2, actually, there's an easier way of getting that than writing out the sequence and looking at it. If I change pen colour down here, if you imagine the sequence going backwards, so 17, 14, 11, 8, 5, the next number down, this is like going down in threes, it would be a 2. And it would be a positive 2, right? It's just an ordinary positive 2, which is where this comes from, positive 2. So if you imagine the sequence going backwards, what would the next term be? That's the term that goes on the end with the n, right? Okay, so this one, let's have a look. What's going on? We are going down in 6. Each time we are taking away 6 every single time. So if we want the nth term, we put that number with n. This is like the minus 6 times table, but my sequence clearly isn't the minus 6 times table, or it would be going minus 6, minus 12, minus 18, and so on. So I need to know how much it's been shifted. So follow the sequence. This time it's sort of going up in 6 if I go the other way. Now 6 more would be 21. The next number would be 21. And that's an ordinary positive 21. So my sequence is, if I change back to blue, minus 6n plus 21. And it's plus because this is positive. Yeah? Now you might have decided to write that a bit neater. Some people like putting the positive number at the front, so you could write 21 minus 6n. Either of those is completely correct and will get you full marks. Right, last one. Show that 181 is in the sequence 3n plus 1. Now I could just write out that sequence until I get to 181, but that's going to take a long time. You know, 3 times 1 plus 1, 3 times 2 plus 1, 3 times 3 plus 1. It's going to take ages to get to 181. But what we can say is if 3n plus 1 is in the sequence, if 181 is in this sequence, then this sequence will equal 181 at some point. So if I write that down as an equation and then solve it to find out what the value of n is, if it's a whole number, then it's in the sequence. In fact, that tells me what term it would be. Now, this solving is actually what we're doing this lesson attached to this. So if you don't quite follow this, don't worry, there's going to be lots of practice. But first of all, let's deal with the number touching n last. So we'll deal with this number first, and I'm going to take away 1. And I'm going to take away 1 from both sides to keep the whole thing balanced, because 1 take away 1 is nothing. So that leaves 3n on its own. Now 180 take away 1 is 180. Sorry, 181 take away 1 is 180. Now 3n is this, but I don't want 3 of them, I only want 1, so we'll split it into 3 equal bits. Divide by that number touching n. Okay, now 180 divided by 3 is 60. In fact, this is the 60th term in the sequence. If I did my sequence, the 60th one would be 181. So, I could write down in my bad handwriting, yes, it is in the sequence. Okay, right, on to the lesson then.